Strip surfacing welding on groove rails. The average design life of tram track rails is 15 to 20 years. The actual life depends on the mechanical impact of vehicles, defects caused by wear and tear including weather and the eventual deficiencies of construction and maintenance. Another factor impacting track degradation is the change in traffic. An increase in traffic and axle load significantly reduces the life of the track. The height of the rails decreases as a consequence of natural wear and tear as a consequence of traffic. In a straight section of track rail wear manifests firstly on the tread of the rails. Worn surfaces are repaired by the use of hard-facing welding. Hard-facing welding also helps reduce track noise complained about frequently in connection with covered section of tracks running in the vicinity of apartment buildings. Such noise may become particularly offensive in curves, where trains generate a shrill creaking sound. Noise reduction of tram traffic across hard-faced track rails is quite perceivable even in the straight section of the tracks. Trams run much more easily, smoothly and free of noise on hard-faced surfaces. One of the high-performance processes used in hard-facing welding for increasing rail height and reducing noise is submerged strip arc welding. The key advantages of this process are as follows: high recovery performance, high speed, deep fusion, excellent properties of welds and full automation if required. It is preferable to carry out the welding work under track procession or in a period of time when tram traffic is low. The first step in the process is the preparation of the job site for welding. The tram track is cleared of all dust and other contamination. Then the corrosion is removed from the surfaces to be welded, and the place of the future weld is cleaned of any oil and grease. The welding equipment is placed in the direction of the welding. Prior to starting the welding, the welder checks the dimensions of the section of the worn surfaces to be repaired. process begins with the preheating of the rails to be welded. Due to the large mass of the rail, the application of the appropriate preheating temperature is especially important, which is to be consistent throughout the entire welding process. There is a choice of preset program packages to be selected on the control panel of the welding machine depending on the objective of the welding, which is to reach the design height of the welding. Then the welding begins with the selected parameters. The execution of the appropriate welding process that results in high-quality welds requires an extremely high technological discipline and the knowledge of the welding operator. Along with the welding parameters, the operator must also consider the need for any corrections due to the eventual divergence of rail tracing, which are adjusted manually. Most of the flux used in the welding can be reused by collecting it with a vacuum cleaner. Having finished welding, the slag is removed, and when the temperature of the weld falls enough, it is finished by grinding using a high-performance grinding machine. Upon the completion of the job, the weld is checked for geometric dimensions. The use of submerged arc welding is a good example of increased productivity. The performance of the automated process is the multiple of manual arc welding. Therefore, the duration of track possession required for welding is significantly reduced. Submerged arc welding is efficiently used in the case of heavy wear and loss of rail height, also for the reduction of noise.